In this video we solve problem 6 of unit 12. In it we have a square of side of length 0.2 meters that have already two charges of plus 5 microcoulombs in two of the vertex, as the figure shows, and we want to bring in a third charge of charge plus 2 microcoulombs from infinity to vertex A. So to calculate the amount of work needed to do this, we have to bear in mind that this is going to be work against the field. So this is going to be the charge we're going to bring, which is, we'll call it Q3, times the difference of potential energy between the final point, which is A, minus the initial point, which is infinity. The potential at infinity is 0 because we take this as the reference point, and the potential at A is equal to the potential at A given by point charge 1 plus the potential at A because of the point charge 2. We can call this point charge 1 if you want, and this point charge 2. So this is going to be equal to, this is going to give you that the work is going to be Q3 times KQ1 divided by the length of the side, which is, we call A. So this is A, plus KQ2 divided by A, which is the electric potential at point A due to point charge 2. So if we do the calculations, this work we have to do against the field is going to be 2 times 10 to the minus 6 coulombs times 10 to the minus 9 newtons square meter divided by square coulomb times 1 divided by A, which is 0.2 meters, times 2 times 5 10 to the minus 6 coulomb. So this work is 0.9 joules. Now in B, we want to calculate the amount of work we have to do to bring the point charge 3 from point A to point B. So this is going to be like this. The amount of charge 3 multiplied by the difference of potential between points B and point A. So we already know what the potential in point A is, so we need to know what the potential at point B is, and this is going to be equal to K Q1 divided by A plus K Q2 divided by A, which is exactly the same as at point A because the distances are the same. So in fact, this difference of potential is 0. So this is Q3 times 0, which is 0. So we don't need, there's no need to do work to bring point charge 3 from point A to point B. And then C, the question is what would have been the total work done against the field to bring point charge 3 from infinity to point B directly. So this would have been Q3 times the electric potential at B minus the electric potential at infinity. So this is 0, and this is equal to Q3 times VB, which in fact is Q3 times VA because they are both the same. It's the same as the work we had to do to bring it to point A.